because the odds are actually pretty bad. How does that relate to statistics? Okay, so we have p-values and confidence intervals. The whole idea in statistics is it's based on a normal distribution. So I have an example here. This is actually my commute time. My average commute time is 75 minutes, and I have a standard deviation of plus or minus 15. Okay, so what does that mean? That means one standard deviation represents about 68% of the values. Two standard deviations represent 95% of the values. So when you're calculating and you're looking at a 95% confidence interval, it's exactly the same as looking at a 0.05 p-value. It's really using the exact same logic. So if I have a value that's here between the 60 and the 75, it's very likely that it's part of that distribution. If I have one that's maybe an outlier, then if I was running if this was a one sample t-test, the red square, I would identify that as being, there's less than a 5% chance that that really belongs to that group. You have to know more than the mean. You also have to know the variation or the standard deviation. If I went back, look how the shape of the curve, even with the same mean, can be quite different. So you have to know both. You have to know the mean and you have to know the variation to understand probability. Again, if this same red X is now within my confidence interval, I would say now that I would not reject my null hypothesis. I would say that this value belongs to this distribution. Now I'm going to do a test of difference. So the blue bell-shaped curve on the left with the blue lines, that's my normal commute time, and it's 75 plus or minus 15. If I commute during rush hour, it goes up to 105 minutes. And as you can see, there's very little overlap between those two curves. So if I were to run this as a p-value, comparing the 75 to the 105, or if I was looking at the confidence intervals, I would conclude that the difference, the chance of these two groups being the same, less than 0.05, and I would reject my null hypothesis. If I compared my morning commute to my evening commute, there is quite a bit of overlap. So if I had a value right here in the middle, I don't really know which group this belongs to. And so in this example, I would actually not reject my null. I would fail to reject the null because there's not enough of a difference between these two samples.